I took that.
All right, so
Good luck.
Papa know about algebra.
all right, so thank you guys for helping me out. So introduction. So what do you guys know about physics?
What do we know about?
Yeah, what do you know about physics?
I know math is used in physics.
Okay. What?
Probably algebra has something to do with it. I have no idea
Mm-hmm.
about physics.
Anybody else? Idea what you think physics may be? Oh, what is it?
I'm not even sure.
Well, the thing about physics, this is why I like physics, this is why I like teaching it. Physics is what you do every day. Okay? You're doing physics right now as you're sitting down. You do physics when you're driving, you do physics when you're sleeping, when you wake up out of bed, you take a step. Physics. So physics has a lot to do with our everyday life, and we put our lives on the line for it because we believe in everything when we talk about physics. So when we're talking about physics, what are some examples? Forces. Okay, you got normal force, gravitational force. We all believe that gravity exists, right? Mm-hmm. So you believe that gravity is something that pulls you down. Some people, it's something that pushes you down. That's a whole other topic for a whole other day. But you believe that gravity is going to bring you down back to Earth, but do you realize there's something that's pushing you up? So when you got something that's pulling you down, there's something that pushes you up. And we call that normal force, but that's a whole other topic for a whole other day. But kinematics, anybody know what kinematics is? Or you have an idea of what kinematics could be?
Does it have something to do with kinetic energy?
Kinetic energy? How do you get kinetic energy? So what is kinetic energy?
It would be two opposite.
It's kind of like magnets with different poles.
Okay.
There's two forces that can't come together.
Like a battery.
Okay.
Only two
Anything?
things.
Like a north and a south.
Okay. Anything else? You didn't finish. So anything else?
I'll go ahead. I want to hear what you guys say.
All right. So kinematics. So you guys are saying good things, but now we're talking about magnetism, and we're talking about Newton's third law, right, or something else. So that's good stuff, but that's again later down the road. But kinematics is nothing but the study of motion. You're talking about movement. So while we're talking about kinematics, well, I'm getting ready to talk to you guys about something called an XT graph. Okay? An XT graph can also be known as a position time graph. Okay? So what is a position time graph? Why do I have this position time graph? Well, a position time graph looks something like this. It's an XT graph, okay? Mm-hmm. Now, if you know anything about graphs, you know that this is the x-axis, this is the y-axis. So that can be very confusing to have an x right here, right? Well, don't look at it like that, okay? You can also see this as a PT graph or a DT graph, because this graph can also be known as a position time, distance time, or displacement time, okay? But when we're talking about position, what does position tell me? Where's the object, right? Where's the object at? And time is how long, right? So what would be the variable for position if we're talking about where is it? Like a distance, right?
Yeah.
So meters. Everything in physics is always in meters. So yeah, we're Americans, we're stubborn standard system. But when we're talking about science, everything's in meters, okay? So position time or XT graph is meters over seconds, because time is always in seconds, unless we tell you it's in hours or whatever, but it's always in seconds. So an XT graph, okay, position, time, this is what your graph will look like. This is a blank graph, so there's no data involved right now, okay? So an XT graph says position over a certain amount of time. Where is it right now, right? Okay. Mm-hmm. So what would a graph look like if I say, hey, this object is moving over a certain amount of time?
It would be constantly moving.
It'd be constant. So good job that you said that word, because this graph is called a constant velocity graph. Mm-hmm. So the object is moving at a constant rate. Right. So that's why it looks like this, right? Mm-hmm. It's moving this way, it's moving up and over,
meters
and over.
And time is moving.
Meters and time is that. So I keep saying meters, time. Meters, time. MS. So the ms meters per second. What is meters per second? What does that stand for? Or what is that?
That's the time it's moving. The meter.
Or
Speed.
the speed.
The speed of it. Yeah.
Speed. So the word that we're going to use is velocity. All right. You hear that when you play baseball. They got velocity minus fastball, right? So an object is moving meters per second, or my object is moving this fast over X amount of time, right?
Right.
So this is what a constant velocity graph will look like. Okay. It's staying at the same rate, same speed, not changing, not going fast, not going slow, it's just moving along. Everybody makes sense of that. Okay. So how can an object move another way? So we know they can move at a constant velocity.
It can speed up.
It can
and
speed
slow
up,
down.
or it can slow down. So that graph is also known as a what? Velocity time graph. This means acceleration. So this is constant acceleration. Well, not really constant acceleration. It's accelerated motion. So only in a XT graph, position time graph, can you have a curve. They call it a parabola, but it's a curvy type graph. So only in this graph can this show accelerated motion. Now, when we go on to a VT graph, velocity time graph, this will look completely different. But right now, I want you to think XT, curvy line, accelerated motion. So that makes sense. So, okay. Any questions? All right. What? Okay. So again, it's curvy, parabola is going up. Okay. All right. Now, we said an object can stay constant. We said an object can speed up. What else can an object do?
No motion.
No motion. So no motion. Object can stand still. Right? So when an object stands still, or the position, right? I'm over here 5 meters up. What did I do? Not nothing.
Not doing
I
nothing.
stayed still. So remember, on the XT graph, if it's a flat line, that means my object is just sitting there. There's no motion, okay?
Time is still going, but there's
Time
no
is still
motion.
going. Why now? Going back to that. X is position.
Your placement.
T
Time.
is time, or my Y and my second. So, if you know anything about independent variables, what is an independent variable? Or what does independent mean?
It's stand alone.
You don't need nothing. You just stand alone. So the independent variable in this is what? It's always time.
Yeah, time. It's always.
This ain't doing nothing. Time's always going that way. Right? You can't go back, you can't go forward. Depending on some people will think, well, they're all time travelers, because you can move faster. When you drive your car, you go fast, you actually go faster. Or your time is slowing down for you. That's a whole other conversation. The independent variable is time, it's not doing nothing. But the dependent variable, it needs something to change. That's the position. Okay? So any questions on that? So let's do a quick little recap. This type of graph right here is a what?
Constant.
Constant velocity.
Constant velocity.
All right, constant motion. Okay. This graph is what?
Accelerated.
Accelerated. Again, if it's curvy, accelerated motion. And then the last one,
No
no motion. This ain't doing nothing. It's just sitting there. Okay. Okay. Any questions with that? All right. So what I'm gonna give you guys right now is this small little worksheet. So since you guys got small little worksheet. Okay. And on this worksheet, we're gonna go over this together, and we're gonna try to identify the words in the boxes to the left and try to match them up to the boxes to the right. So look at that for a second. I give you guys a few minutes to just try, and then we're gonna come back and do it again. We'll go over it
I need my
together.
glasses. Moment. Travels towards home.
You can collaborate. I promote collaboration. Just don't cheat.
How do you want us to do this?
So in the box, you can put like A, B, C, D, or however you want to do it.
Okay.
Oh, nice. Okay.
Ooh. Oh, this makes sense.
All right, now since I got that reaction, this is what I want you to think. Okay, I want you to think. Remember, you got your three different graphs, right? Accelerated motion, constant velocity, no motion. Okay. Now understand, all of those graphs were moving in a positive direction. Okay. So what would a constant velocity look like in a negative direction? Look like this,
Okay.
right? If it's constant velocity or it's moving regularly down the street, not going fast, not going slow, it's constant, it will have a negative slope. And we'll talk about slope in a second. So what would accelerated motion look like in a negative direction? It will go down.
It won't go down.
Yes, it will go down. It can go down like this. It can come down whoosh, like that. So if I'm going for, if my position time graph, it can go like this, right?
And you said that was what
It
again?
could be negative. This is accelerated motion, but it's in the negative direction.
Oh, okay.
Now, I don't say deceleration though.
So
It's
instead of
just
using-
accelerated motion moving in a negative direction.
So stopping would be a accelerated motion.
No, stopping is stopping.
Stop, yeah.
Okay, so slowing down
Slowing down.
will be.
So if an object is slowing down, what would it look like on a
it would be
XT
negative,
graph?
right?
It won't be negative. Okay.
Impossible journey and not moving. That's your meters, time is just staying right there and going nowhere. It's impossible.
You know what's crazy about this?
You should know this stuff.
He
I
knew it all.
should, because I deal with this.
That's what I said. Thank you.
So let's go ahead and
I'm
go
throwing for a
over.
loop. I ain't gonna lie to
I know, I
you.
ain't got it right, bro.
Okay, so the first thing I'm gonna say is we'll go over the ones that's really important. There's a couple of them that I ain't gonna lie to you. It's kind of hard to figure out. But let's go over the ones that's kind of important. All right, which one was not moving? What do you think?
I had
D,
F not
F.
moving.
You had F was not moving.
I got D and F.
D and F. Pop. Which one was not moving?
I had D as not moving.
D is not moving. All right, so again, yes, D is the one that's not
So I
moving.
had it
Now
right.
remember, an XT graph, if
I
it's
should
not
have
moving,
left it
it's a what? Flat line. Okay,
Yeah.
it's flat across. All right, it's not vertical. It's the one that's flat across. Okay.
Oh,
All
I
right.
already know I got some of these wrong.
So I had
Now I'm
D and
looking
F,
at it.
so
I
I
got
get
it.
half?
I got it.
No, that's fine. You said D, and it's fine. So we know
But I
it's
did
D
say
because
D
remember,
and F.
no motion, it's flat line. Okay.
Okay.
Which one
I had it right at
was? Which one was a speed up? What does speed up mean? That means what? What's
Speed
the
up,
word I'm looking for?
should've-
Acceleration.
Acceleration.
Should have
So
been
which-
H.
So which one shows
I said
acceleration?
8.
Mom?
I believe that's what you had. Check.
All right. So acceleration, speed up. We want to go fast. So it starts from 0 and goes fast. So that's going to be
E.
A.
I had 8.
A is the one that's
That's what
accelerated
Jerry-
motion. Okay. Remember, if it's speeding up, we said we move in the positive direction. It
So
accelerated.
this is
So speeding up is A. Okay, speeding up is A. Well, it's the opposite of that. Okay. All right, next. Which one is the suddenly stops? So it was traveling, and we're going to assume it was traveling at constant speed,
Right.
and then it just stopped.
H.
What y'all get? Mom?
I didn't put that
You didn't
down.
put
Well,
that-
you said, oh, this is
No. This one is
those that step. You
suddenly
said,
stops.
no, but I
You
put
didn't put that on
next,
there?
I put G wrote on it on here. I didn't put it in my box.
Yeah.
What do you put, Pop?
I put G,
But
But
that's wrong.
I know it's wrong.
I might be right.
All right, the one that suddenly stops is actually H.
Oh, okay. I was
Remember,
right.
it's
I was right.
constant
right.
speed, and then it just went.
Man,
Stop.
That's what I was just telling you when I said, as I'm looking at it now, I know which one is which.
Right.
And I was saying H, that's what I said to you.
He makes it. He when he said explaining it, it
Yeah.
sounds but like it clears it up in my mind. So
Okay.
yeah, okay.
All
I
right.
got it right anyways.
All right, now which one is slowing down to a stop? This one's a little bit tough.
Slow
B.
down and stop.
Slowing down to a stop.
This thing.
G that
G.
I think that I put G, but I think it's B
It's B.
Why did you say B?
because the way it's accelerating. But then, as it when you can tell that it's slowing down the acceleration,
That's the curve
it's slowing
coming.
down, and the curve is starting to level off,
Perfect.
which makes it.
So yes, that one, the one talking about slowing down to
Yeah.
a stop is B. Again, we're slowing down, we're speeding up. That's talking about some sort of curve, right? That's acceleration.
Hear it now.
So it's here comes to a stop, right?
Right. Yeah.
Okay. Now
Good job. Good spelling.
the next two I'm gonna give you, and It says one says travels towards home. So again, everything just assume it's constant velocity. So that means I'm at a position and I'm coming back home. Which one is a position and I'm coming back home?
You said
In other words,
It's like Jay is traveling.
well, check this out. In other words, if home is my starting point, but my position, or I was somewhere else, okay? What is my graph going to look like going back home?
Should be
like opposite.
I'm going to ask you a question. Is it going to be, wait, is it positive or is it negative?
It'll be negative.
Okay, so if you say it's negative, then it can't be I.
It would have to be J.
This one said Jay.
Okay.
If you're traveling towards
I'm coming
home,
home.
And then come back. You
I'm
went
coming
that
home.
way, you
So-
come back.
the only one that makes sense to me would be J.
Okay. Anybody else? So let's look at it. So we're assuming everything is constant velocity, right? Okay. Now, if home is my start,
Right.
and I say I'm coming home, where do I start? At home
At A.
or somewhere else?
Somewhere else.
So I'm going to start, let's just say right here.
Okay.
So it'll be E.
So am I coming home,
You don't
over time, what I'm going to look like?
Yeah, time is still going to have to go.
Right.
You can't stop time.
So what is that one?
G.
So it's G.
Everybody got it? Okay, it's going to be G. So again, we want to assume everything is constant velocity unless the question said I'm getting faster
So
or
this is G.
I'm slowing down
Travel
the speed.
towards home was G.
Yeah. So which one will be the one that's traveling away from home? If I'm starting at the house and I'm leaving the house, which one is that?
That would be E.
Why? Because it's the opposite, right?
Correct.
Since it's the opposite of it, perfect. I'm traveling away from home. Okay. Or leaving. Okay.
I got that one right.
Now the one I like the most is this one's funny. Which one's the impossible journey? Or any, the one that's like
F.
At 4 seconds I went from the bottom to the top, right? It's the one that just goes straight vertical.
Yeah.
Okay. So
Yeah.
that's F, okay. Any questions? Alright, other ones we ain't gonna do, so if you answer those, good job. I want you to think about it.
Well, I'm actually enjoying this, man. So the thing was, you can't look at it and say if you use one, you can't use it again. You just gotta.
Yeah.
Because-
Because you could use it for again maybe another one, okay? But with the wording of the questions and everything, for this one, yeah, everything's going to be used once, but there are going to be I think one or two that's not going to be used. The graphs on the right. Okay.
If I have a question about it, I'm gonna use it.
About like what? You talking about goes at a steady slow speed,
Yeah.
goes at a steady fast speed? Which one do you think goes at a steady slow speed? And that's gonna go and segue into the next one. Steady slow speed.
I
Why?
because it's moving, but it ain't. Even though it started up here on the graph, it really isn't going that fast.
Correct.
The meters aren't changing much, but the time is still moving.
So going into the next part, I hope you realize that, and you realizing that. If you have a graph that looks something like that, okay? If the slope is not, again, the slope, what is the slope? I'll tell you in a second. But if the slope of the graph is kind of almost flat, then that object ain't moving that fast.
Right.
So what would it look like if the object is moving fast?
It's gonna look like a curve.
And it's going to look like a curve. It's going to look really steep.
Well, steep. That's
Right? So it's going to look really steep. So for example, you know how we were kids, we were going down a steep hill? How fast do we go? Right? But you don't really get no speed if you go down like a gradual hill, right? It's going to take time to get fast. But you still get fast. It's a whole other topic. But it's going to take time to get fast. So this one's moving slow.
Slow.
This one you're moving fast.
fast.
Everybody understand that? Okay.
That's
Same thing when it comes to acceleration. If I have an acceleration, or if my XT graph is going to get faster, but it curves really slow, that's a slow acceleration. But if it looks like this, where it curves up really fast, then that's a fast acceleration. Everybody got that? Any questions? Okay. All right. So moving on. Now I'll talk to you guys about slope a little bit. How do you find slope? If you remember, how do you find slope?
How do we do it?
How
Define
do you
slope.
find slope?
How do you find slope?
Yeah.
Not as flat, not as close.
Okay.
It's not a level out. It's, I'm not sure.
Slope is is it still time and distance?
Well, it's going up on a vertical curve, in my mind, to where it wouldn't be a sudden takeoff, but to get a slope, you would have to gradually, on a curve incline.
All right, so you guys saying really good stuff, but here it is. You can't ever be wrong. Everything is right. It's just got to fit into the right piece. So slope is rise up over run across, right? It's the up versus over, Okay. So if you want to find slope, you got to find the rise over run. If you have a graph that's kind of weird, for example, like these graphs right here, we're talking about it's going fast or it's going slow, then you can find the 2 points on that graph that hits on a graph, and you circle 2 points, okay? And you take the x2 minus x1, y2 minus y1, and we'll talk about that in a second. So again, to find slope, it's rise over run, or you can say x2 minus x1, y2 minus y1. Now, why am I telling you this about slope? Why are we talking about slope? I told you a position time graph, and I said it tells me where the object is over a certain amount of time. But then we said a word called velocity, right? So why am I telling you how to find slope? Because we need to find what?
Lowest and the highest points.
No, not that.
You have to know slope because you have to know the position.
How to know
To
slope?
know the distance, height.
No. So as we looked at these graphs, right? We said it's an XT graph, right? So we know what's X standing for? Distance. The meters.
The meters.
And what's the S? Time
Time
for
seconds.
S. So meters per second. What sounds like meters per second? We all drive, right? So let's relate that to a car. Miles per hour.
Okay.
So what does that tell you?
How fast
How
is
fast
I'm
fast,
going.
the speed.
So in order to,
Fast
we need to
speed.
know slope to know what?
the speed?
The speed of the object. That makes
Okay.
sense?
Yeah.
So that's why we're talking about slope.
That tells how fast it's
That
gonna rise
tells how
or fall.
fast that object is moving. Okay? That tells us how fast that object is moving. So, and it's easy to determine. Again, I didn't give you any numbers on those graphs, but we do know, hey, if it's a regular old slope. All right, so,
Stands in a positive.
Well, it stayed at 60.
all right,
It
so,
constant at 60.
I don't know where we stopped on the camera, but we're moving on. So again, we did the first part of this worksheet, right?
Right.
Again, that's basically a review of what we've been doing. So it seems like you guys get that. Good job. All right, so as we turn the page, now you see a graph. You got numbers. You actually have a graph. And now the question is about to get a little bit more challenging, but you should have a better understanding of what we're looking for, okay? So, first question. It says, during which time interval did it first travel in a positive direction? So where is it when the object traveled in a positive direction first? Between what time period?
0 to 15.
Not 15.
10.
0 to 10.
Okay.
Yeah, okay.
So between 0 and 10 seconds, my object moved positive. How do we know that? Because the
Because it
graph
went
is
up.
what? Moving up.
It's moving upwards, yeah. I got you on that.
Moving up. All right. So the second one. During which second time interval did it later once again travel in a positive direction?
I got
40 to 55.
40 to 55. Anybody else?
Can we go backwards?
right here, yeah.
Between 40 and 55.
Mm-hmm.
All right, so again, the object is not moving backwards, moving forward. It's not, it's going. Now remember, it's a position time. So in a position time, Okay.
Cat came to class.
And a position time is telling me. So if you look, if this is my start, I am moving away from my house. I am moving to my house.
Right.
I'm moving in the negative direction. I move behind my house. I move back to my house. That makes sense? Okay. Any questions on that? So again,
Can you explain that behind the house thing?
all right. So okay, here we go. This is me. This is my start, right? This is my positive direction. That's my negative direction.
Behind. Okay.
So if I want to move to 60, I'm moving
Forward.
to 60. Okay.
Gotcha.
If I want to move to negative 20, I'm moving to negative 20.
Gotcha.
Okay. Think of it like this: on a football field, right? Your line of scrimmage, 10-yard line. You're moving the positive direction to the 30-yard line. You're going forward. But said hut, you got to tackle for loss, so you get a -5. So that's not kind of the same thing. My position on the football field, I either move forward from where I initially start, or I'm moving backwards. Okay? Now, time still goes, so if I moved backwards, if I started at 0, I'm moving backwards, then my time still goes and I'm moving backwards.
Right.
All right, that's a negative direction, correct? All right. That makes sense?
Yeah.
All right, which time interval did it first move in a negative direction?
15 to 20.
40.
Between 15 and
You
40?
said
It was 15 to, yeah.
What's this right
Sorry.
here? This is going backwards, right? I was looking here.
Yeah,
Everything, this
15
is
to,
That's
positive
up
direction.
positive. So I'm going
So if
back.
it's going back to 0, it gives it xt. So if it's going back to 0, that means it's moving backwards
So
or
it's
coming
negative.
back to it.
That'll be negative.
So from here to 40, like Jay said, this will be the negative motion. This is moving
So over
negative.
here.
Yes.
Oh, yeah.
That makes
That's
sense?
solid. Yeah, I got you now.
But on here it got this the 15 to 30. Is it because you're meeting at the timeline here?
40
Well, they're
to 60.
stopping it probably at the 30
At the 30.
because you won't get back to
The time.
back
Yeah.
to regular where you was
Oh yeah, that's so. Yeah, 15 to 30. I got you.
at. Does that make sense? All right. Any other questions?
I'm with that one. Yeah, I
All
got
right. Now here you go. The second time. When was the second time it moved in the negative direction? All right. That one may be
30 to
confusing, but it's
40.
the 30 to
30 to
40.
40.
Okay. That's the 30 to 40. Okay.
Because this is it's 15 to 30. They're stopping you at the baseline, and then you're going. The next one will be the 30 to 40.
Okay.
And there's only 2 times it's going in a negative direction
All
on
right.
this graph.
Does everybody get that? All right. Any questions so far? Any questions? It's good stuff. All right. Now let's think about this real quick before we really move on to the next page. How can you relate this to your everyday life?
Well, if you look at it in my everyday life, as I wake up in the morning, and
Where do you start? So let's say you had a graph. Let's say this is your graph, and when you wake up, you're at home. So where is it on the graph? At the 0 point, right?
0.
Okay.
This would be zero.
All right. Here, this question wasn't on there. Where is on the graph when the object's at rest? Or not
This,
moving? Where on that
From,
graph where the object's not moving?
from 10 to
10
15.
to 15, right? All right. So
Yep.
with that being said, go ahead, finish.
Well, if you look at it, if you take from 0, I get out the bed and I start as a positive motion from the time I get up to going and washing up and getting ready to leave to go to work. And then if you take that part where it's not really making a motion from the 10 to the 15, that's my lunch break.
Okay. Because you ain't doing
I ain't doing nothing.
So
I
you
got you.
ain't, you ain't moving.
And, and so if you take that 40 to 55, that's after lunch, and I get back busy and going, and then you take that 15 all the way to 30. That's my travel from work to home, and from the 30 back there when I kick off my shoes and get ready to supper before I go to bed.
Okay. All right. Jay, you want to tell me one? If you got one.
I know
You
basically.
don't have to use that graph, but like, give me an example.
So, all right, my graph would be a little bit. It would be kind of the opposite of you guys because I work at night. So I'm at rest during the daytime,
Okay.
and then once I get up to get ready for work, I get in the car and I'm heading to work. Then I'm at a accelerated. No, well, yeah, because I'm normally running late. So I'm at accelerated motion to get to work, and then I'm constant. Then I'm at a constant. Time is moving, but I'm at work, so I'm there. And then by the time I get ready to come home, then
Now you said you constant at work. Are you constant at work, or are you really at rest at work?
I'm at rest.
Your position.
My
is not
position
changing.
isn't
Gotcha,
changing.
gotcha.
I'm there,
All right.
unless I have to move to a different location doing my work.
I got you. So that makes sense. Again, my HT graph would be: I'm at home. All right, I'm at home. Then I'm traveling. Boom. All right. So I'm here at home. Then I'm traveling to work. I get to work. I come back home. So it's a very simple graph.
Yeah.
All right. It's here, here, here. Okay. That makes sense, folks. Any questions? All right. So on the back page, so you turn it. Okay. Now this one is talking about really how can we find the slope or finding the velocity of the object that's moving. That makes sense. So it says right here, how far. This one talks about distance. So how far did the car travel in the first 10 seconds? In the first 10 seconds, how many meters did it go?
10 meters.
Hold on.
Oh, sorry.
Think about it. Look at
60.
it. I went how many meters in the first 10 seconds?
60 meters.
How do you get that?
Because you're starting at 0, and from 0 you traveled at a constant speed, which by the point you got to 10 seconds, you was at 60 meters and it was at a resting point.
Okay, so you get how we got that, Pop? So this is what he said. If I started here at 0, in the first 10 seconds, I traveled 60 meters.
Yeah.
That makes sense now?
Yeah.
You good, Mom?
Yeah.
Okay, so the first 10 seconds I travel at 60 meters. Now let's think about the word slope. How fast? Now we want to know the velocity. How fast did an object go? So again, it's rise over run. So how many did we move up? I'm going to give you this one. 60, right? I moved up 60 in 10 seconds.
Yeah.
So my rise, my up is 60, and I'm over 10 seconds. So what would it look like mathematically? So it'll look something like this. It'll look something like this. It's very simple division. Division. How fast is my object moving? I was 60, that's the rise, over in 10 seconds.
Right.
So what's the simple division? What's 60 divided by 10? So my object was moving at 6 meters per second.
Meters per second.
Okay?
Wow.
Simple division. 60 divided by 10, or 10 goes into 6, 60, 6 times, meters per second. Why meters per second? Because that is a unit for velocity. That makes sense? Jay?
I think I probably could have done a lot well in school if I ever had a teacher like this. Real talk.
Does that make sense though, folks?
Yes, actually it did. It did make
linking
sense.
it together now.
That's how you do it. Alright, anything else? Alright, so look at the next one. Look at the next
6
one.
meters
Alright,
per
let's say, briefly describe this behavior. Alright, so we're going to answer this question. The behavior of the object at 10 to 15 seconds, right? Or what is the object doing between 10 and 15
It's
seconds?
resting.
It ain't doing
It's
it. It's resting. No motion,
No
right?
motion.
Again, that's very important, okay? And when you talk about a VT graph, then I'll blow your mind. That's when you lose it. But for right now, know this. Flat line, XT graph, no motion, okay? So that's what it's doing on the next question. All right, so how far did it travel between 15 seconds to 30 seconds?
How far did it
How
travel?
far did it travel? So what's the distance between 15 and 30?
15.
60 meters.
Why is it 60 meters?
Because it's going from this point, which is 60, to the next point, which is 0,
So from 15
15
to 30,
from
it's
15 to
60
30,
meters.
60
Everybody see that?
Mm-hmm.
Again, at 15, all right, I
Which
was
will
at
get you
60.
negative 6
When
meters
I got
per
to
second.
30, I'm at 0, so I went from 60 to 30. That makes sense?
Sure.
So look, if I started here, all right, this is where I was at. Cause I ain't left-handed. This is where I'm at, right? At 15 seconds.
Okay.
And when I get from 15 to 30, my position changed from where? 60
60
to 0.
to 0.
So what's the distance traveled? 60 meters,
60.
Right.
right?
Right.
In what direction though?
In a negative
Negative direction. Okay,
Negative.
that makes sense?
So it's
All right.
6.
So, how fast will the object moving in this time interval?
It will be a negative number. It's still
So
going
how
6
fast-
meters, negative 6 meters per second.
Is it going negative 6 meters? Because how many seconds did I go from 0 to 10?
Sorry.
Seconds.
All right, hold on. Yeah, we're looking at a different. It's a different thing on this one.
Yeah.
So it will be.
Just by looking at it, is it faster or is it slower? Just by looking at it.
It's going to be faster.
Slower?
No, it's going to be slower
Why are you coming to that conclusion?
I say fast.
because it's going the same amount of distance over a more time.
Okay.
So it's going to be slower.
So it's going to be slower. All right. So again, the rise is how much?
60.
60. What's the run now? So how many over did it go?
15.
5, 10, 50.
15.
Right?
Yep.
So
So 60 over 15.
what's the slope?
The slope is going to end up being 60 divided by
60
15
divided by 15. You
So-
said who, ma?
4.
4 what?
meters per second.
Meters per second. Why meters per second? Because
that-
that's velocity.
Yeah, that's the velocity.
Now, this is wrong.
What is all wrong?
Yeah, because we're missing one word. In what direction?
In a negative.
So
So it's going to be a negative.
Negative 4 meters per
Yeah.
second.
Negative 4.
Yeah.
Oh, okay, gotcha.
Okay?
And put that little negative sign up there.
That makes sense, folks.
Oh, yeah.
All right. Any questions? Any questions? Are we good?
Yeah, yes, sir.
I'm with it, man.
All right. So again, we're gonna wrap it up. But the next two is going to tell you is going over how to find slope again for some more questions. Okay, so if you want to do those, you can go ahead and do those. And then that last one talks about what is the total distance traveled. Okay, and now we're talking about area under the curve and things like that, but that's another lesson for another day. Any questions? Comments, concerns?
Good, great girl.
Roll Tide, roll Eagle.
We don't want to do these
Go
all
Tigers.
together.
Now that's your homework.
We got to come back then.
You got homework.